So new parts have arrived for the LS2As, here the original crossovers, with a 4.7, a 10 and a 7 microfarad cap. So I've bought poly caps for these. These are really good, used them a lot. For statin. So we got a 10, we got 4.7, and I couldn't get a 7, so I've got a 6.8, but that's within 5%, and some new resistors. So we're going to replace that resistor as well. Going to keep the air core inductor on the tweeter and the ion core on the woofer. I'm not going to replace those. That's really good. Could replace that for an air core, but I'm not going to that bother with these, so I'm going to get those in. Right, so that's one of them done. So we've got our new components. We got our 6.8 in place of the 7, our 10 and our 4.7, and our new lovely resistor, 1 ohm. So that's the original, and that's the new. So yeah, pretty spot on. I could replace that with an air core, and then we'd be as pretty much as good as we can get, but yeah, for the value of these speakers, it's just not worth me doing that, unfortunately. So this is a really good upgrade, especially on that tweeter circuit. So yeah, I'm going to crack on and get the other one done, and then they can go back together. Right, so I'm going to put the crossovers back in now, and on the terminals at the back there, you can see the nut holding the binding post on. The way these go together, you have a steel washer first, and then you have, if you can see that there, a copper washer, and that's the part that connects to the printed circuit board. And then your circuit board goes in, and then you have a steel washer and a nut. So that copper washer gives you really good contact against the board. So yeah, because the traces are on the back of the crossover board. As you can see, nothing on the front, so all the contacts are made on the back, hence the copper washer. Right, so there we go, all back in. So now we've got our cables here to reconnect, and we're not going to use these push fit connectors. We're going to cut those off and solder, so we get a really good connection, because these are going to introduce a bit of resistance, a bit of noise. So as we go on to the bother of replacing those components, we want this to be really good. So on with that part. Right, so the foam's back in there now as well. Piece at the top, piece at the bottom, and the wraparound piece. I've put a little slit in there for the cables to come through, and also to hold them so they don't get in the way of the drivers. And the ports all stuck back in there now. Right, so the woofer's soldered and back in, and I've just clipped off the crimp connections and tinned those up, so they're ready to be soldered on the tweeters. Right, there we go. So tweeter back in, woofer back in, baseboard glued in. We've glued the cabinets back together, rebuilt the crossover, keeping the iron core inductor on the woofer, but there you go. So yeah, I thought these were pretty good to start with. So I'm expecting them to be even better, because we did find some problems. So yeah, that one's back together. So I'm going to put the other one together now and then give them a listen up. All right, thank you very much. So I've finished doing the crossover work on these little Rogers LS2As. So I just want to give them a quick test. I'm doing this indoors in the office, which isn't ideal. I'm going to get a bit of room gain, probably towards the 200 Hertz area. Yeah, and it's not going to be amazingly accurate, but it's going to be good enough for what we need just to prove the speaker. So I'm going to be doing this again using my calibrated mic and audio tools. I'm going to use this on a different setting that to what we used yesterday. I'm just going to do a peak store and sweep through some frequencies on my signal generator, Unfortunately, you have to do that quite slowly. But yeah, it works well, and it does give you quite a good representation of the speaker. Good enough to prove the speaker after you've done the repairs, and it's quite accurate. So what I'm going to do is start from about 1 kilohertz and come all the way down. I'll show you that without boring you. So we're going to hit the resonance of the room soon. So we're going to get an unnaturally loud area. Right, so I'll stop it there. I won't go any higher, just to show you this. So you probably can't see this very well, but from about 250 hertz up to 1 kilohertz, we are probably plus minus 2 dB. We've got a bit of a drop off here, which is probably where the little woofer's rolling off, and then the gain, which is where the port is probably coming in. So yeah, that's kind of really good. What I've done, the sound pressure level stated on speakers is normally done at 1 kilohertz at 1 meter, and these are about 88 dB, I think. So what I try and do is start at 1000 hertz and dial up the volume until I get to that, and then I'm kind of referencing the same sort of sound pressure level as the manufacturers did. So what I'll do off camera, I'll continue all the way up to 10 kilohertz, and then we can have a proper look at the signal sweep. Right, so I've finished doing that, and probably can't see this very well, but really from 250 hertz all the way up to 8 kilohertz, we've got a line here which is 85 dB, and we probably go above it 3 dB and below it 2. So I would say we're plus minus 2.5 dB, which is really, really good. And we can see the roll off here at about 250 hertz, and then a rise again. Like I say, I think that's probably where the port comes in. It might just be the characteristics of the room, because it's not ideal to do this inside, or I haven't got an anechoic chamber, so yeah. But you can kind of see the BBC dip that people talk about, which is the same as the loudness curve. So high frequency, and we sort of have this dip and then a rise again. And I think that's one of the things that the Rogers speakers, the BBC monitor design was famous for, because our hearing at low level isn't as good high frequency and low frequency. This Munson Fletcher curve was worked in that kind of lifts up the top end and bottom end, so like a dip in the mid-range, and you can kind of see that there. So yeah, these speakers are really good. Like I say, we're plus minus 2.5 dB from 250 up to 8 kilohertz. In fact, more like 10. I don't measure above that. There's not much I can do about it. So yeah, pretty good. So these little speakers are ready to go. Hope that's been pretty interesting. Catch you on the next one. Thanks for watching.